Hi, welcome back. This is Laura Grayson Roselli. I spent many years working in the biopharm industry as well as teaching in biotechnology and biology programs at various colleges. And so I want to help to answer some questions that my students as well as friends and family have about the pandemic and vaccines and variants of this SARS coronavirus 2. Let's first remind ourselves a little bit of what you may have seen in previous lectures, and that is, what does the virus actually look like? So here we have the coronavirus, and the virus is made up of a bunch of proteins that we see on the outside here, and also on the inside it's made up of RNA. RNA is simply the instruction manual that the virus and our cells use to know how to make these different proteins. And the proteins are really what your immune system sees and how your immune system fights off the virus. Now, in the case of SARS coronavirus 2, we're really concerned with this one protein here, which is called the spike protein. The spike protein is used by the virus to get into your cells, the host cell. And once in there, it hijacks all the inner workings of the cell and convinces it that it needs to make many, many copies of the virus and stop doing what it's supposed to be doing for you. The variants come about, as we mentioned in a previous lecture. The variants come about because when one virus gets in and thousands are made within that one cell, sometimes there are changes to the RNA, which means changes to the proteins. And those proteins may change a bit. So instead of having this straight stalk here and this circle, which is really a little bit different than the virus looks, but for illustrative purposes, maybe instead I get this protein that looks a little bit different. So it's still a spike protein, but it's kind of like a sister or a cousin spike protein. Now, why does that matter to you? We need to know a couple of different things. How will this change in the spike protein? How will this new variant have an effect on the transmission of this virus? So if I'm infected and I cough, is my neighbor more or less likely to be infected by that virus? And also, how likely is this new version going to cause greater side effects or greater effects when it infects me? So is it more lethal? Are the symptoms more severe? And then thirdly, we need to think about whether this new variant is going to be recognized by your immune system. So let's remind ourselves what that's all about. So again, if we take a look at the original variant here, right, here's our original protein. When we talk about an immune response, immunity is really, really complicated, but we're going to focus on one part, and that's antibodies. Antibodies are made by your B cell, and antibodies, if you were infected or even vaccinated, you can find antibodies that are floating around in your body that recognize, and by that I mean physically proteins touch proteins. And in the case of the vaccines that are being delivered now, or the infections that those who have been previously infected may have been this variant. So we created vaccines that will let your body make this protein, and then your immune system learns how to fight this protein off, so that when in the future you're infected with this protein or this virus, you have the immunity, the antibodies, and the rest of the memory of your immune system that knows how to fight it off. The question is, when you have a variant that is different from the original, will your immune system continue to recognize and know how to fight off these other variants? Let's talk a little bit about those variants. There are crazy names out there that sound crazy to those who are not working in the field, but B117 or the UK variant or the D614G variant. Now, there are different reasons we can discuss in future lectures that we use that terminology. But when we talk about this D614G, let me just explain that in this whole big long amino acid chain, that's just a single change in there. And so some of these changes are very small, and it is still likely that the vaccine and the antibodies created by the vaccine will still be effective against those other variants. The reason we don't have the absolute answer to that at this point is because those variants haven't been out or haven't been studied with the current vaccines enough. So you may have heard in the beginning that Johnson & Johnson vaccine had effectiveness against these other variants or some of the other variants. And that's because when they were testing, they could test people that had been infected with those variants. We are currently looking at whether the Pfizer and the Moderna vaccines are also effective. And as we said, there is a chance that they are, if the antibodies can still recognize both of these proteins. But studies need to be complete before they can say that and be assured that the vaccine will be effective. One of the things that we need to remember is that the more people that are infected with the virus, the greater the chances that new variants will form. It is like a domino effect when one person infects another and another and another. And what we need to do is we need to stop those dominoes from falling. We need to stop the transmission so that we can stop the different variants from being formed. So you want to make sure that you get vaccinated, and it looks like this is available to people 16 and above as of April 19th. So it's important that we stop the dominoes, and therefore we can decrease the number of variants that are created. I hope this helps to explain what variants are and why it matters to us. Stay tuned for a future lecture on this and other topics in biology.